Well, where's it at? There it is right there. Okay. All right, guys. So here we go. Uh, this is number 9, guys. And we will, let me get my mouse out of the way. I haven't used this whiteboard in a while, and you guys all know how horrible I am at it. So we'll see what happens. Okay, so that's working still. So I kind of pre-did some things here. So for those of you that are having a little trouble with these, uh, one thing that's helped me, and some of you are doing much better than I am at some of these things. So, but I'm willing to learn while you guys learn, and just give me a little grace sometimes, and I'll figure it out sooner or later. I had to teach myself one time, I'll do it again. So when we're looking at this stuff here, number 9 is the Taylor polynomial centered at x equals 1, and we're going to approximate using the function natural log of x. And what degree polynomial for being at natural log of 3/4 with the error less than 0.001. So this problem in general kind of covers a bunch of good things, but what I have found is I kind of work with what I'm given right off the bat. So it helps me kind of fill in some things. I know I'm kind of all over the board here. So let's just work with this right here, this area in blue right there. So this is what I'm given. I do know that I'm dealing with natural log of x. I do know that it's centered. I do know that it's centered at 1. I do know my x value is 3/4. So we're really looking for an error between 3/4 and 1. So that's going to be, the distance is going to be 25, 0.25. So we're going to deal with that when we plug it into the error. So there's our x minus c, or in some cases, you'll see x minus a. Excuse me. Now, what we're looking for is some z value. And if you guys remember, z is some value, and I didn't do a very good job right there because, you guys, if you guys remember, I'm really horrible at drawing straight lines on this thing. Uh, we're looking for some z value in between 1 and 3/4 on a natural log, but we're also dealing with the fact that the error is the uh, absolute value. So uh, we got to look for the spot where it's going to be the biggest value based on like an absolute value system. So when you plug in 1 to natural log of x, you get 0, and then 3/4 is going to be off of 0. So 3/4 is going to be our our maximum number we're going to deal with when we're looking for this. So that's that whole idea of what are we looking for here, okay? So when we deal with that, we know that that's the value we got to deal with when we're dealing with our f of n plus 1. So as we look at this, we know, and this is where memorizing your generic formulas. And I drew another purple little thing there. Let me do it. Let me do a different color. And I don't know if this is going to work out for you guys because of how I did it, but I just went ahead, and since I already know these things, let's see if this works. Does this work? Here it goes. Uh, since I already know these things, I need to come up with my derivative plan. And there's a -1 part to the front of this, but we don't really worry about it because it doesn't matter because we want the absolute value. So as I move this way, I just kind of know that I'm working from this general formula, but remember the error is for uh, the next term in the Taylor series. So it's f of n plus 1. So I just took n plus 1 and I plugged it in for all the n's right here. And so I took n plus 1 and I plugged it in right here, and I took n plus 1 and I plugged it in right there. Now, when I did that, it kind of set me up for a little bit of different setup here. So I get 1 minus 1 on top, and so I just get n factorial here. And then on the bottom, I get an x value, which is probably going to be my largest error anyways. I get an x value from right here of 3/4. Now I'm totally making it ugly. Of 3/4. And so I get n factorial 3/4 of n plus 1. So now I just kind of do a little bit of algebra. I don't like this idea. It's hard to put it in the calculator. So I take the n factorial and I flip my fraction over and I get 4/3 n plus 1. So that is my f of n plus 1. Oh, man, that's ugly. So this is my f of n plus 1 of z. Let's go back to this. Yep, that'll work. This is my f of n plus 1 at some value of z, right? Well, we know that largest value is going to be our 3/4. So that's kind of what we're dealing with right now, okay? So that's where we're at here. So I have the first part of my error. So when we're dealing with that, we're going to take our idea of the absolute value of the error, right? Has to be less than, let's do this. Has to be less than f of n plus 1 of z and times x minus c n plus 1 all over n plus 1 factorial. So we've got this piece right here. I don't remember, it can be x minus a. It doesn't really matter. Just be consistent with what you use. I like C because it reminds me of C. So some people will use like X minus A and then they put C here. I like sticking with the fact that this is the center, this is the X value, and Z is some value in between that we're looking for the maximum error. And so we just want to make sure that the error doesn't go over. So if we clean this up and we rearrange it, we already told that the error is, let me clean this up a little bit, n plus 1 over n plus 1 factorial. We're already told that this error needs to be less than 0.001. All right, so let's clean all this up. So now I'm going to take this part here from what I was given. I worked my way through to this. I'm taking this part here, and I'm going to plug it in right here. So let me change it to green so you can see what I did here. So I'm going to do n factorial times 4/3. That's a 3. That's a horrible 3, guys. I haven't done this in a while. 4/3 factorial. Nah, not factorial. What am I doing? N plus 1. I would do this on a whiteboard, but I'm not at school right now. And then I'm just going to break these into pieces. So I'm going to leave x minus c. I'll do it here. I'm going to do x minus c, but we already know what x minus c is, which is going to be 0.25. So 0.25, and this is going to be n plus 1 times 1 over n plus 1 factorial. So at this point, you would start plugging in your n's over and over again, and you'd find a value that is less than 1 here. And that becomes tedious because you're going to plug in 1 and you're going to calculate the error and see if it's less than 0.01. Then you're going to plug in 2 and you're going to and then you plug in 3 and then you plug in 4 and then you plug in 5. So let's start using our calculator to help us out here. So what you're going to do is you're going to do a y1 like it's a graph, and we're going to change all these values to x. So you're going to type in x factorial, and then you're going to do next to it 4/3 x plus 1. So you're just really letting n equal at x. So then and I'll write that here. So right here, we're going to put let n equal x, just for the sake of calculators. And then we're going to do 0.25 times x plus 1. And then we're going to do 1 over x plus 1 factorial. You plug this into the calculator, a couple of different things here. And hopefully I can finish it off on the screen. The factorial, you go to math, probability, and then scroll down to number 4, and that one is going to be factorial. And you can put all your factorial signs in with that. And then you're going to go to table setup. I'm just going to move this up just a little bit, guys. We're going to go to table setup. We're going to go to table setup. And you're going to do change in X is going to be 1. And I would start at 1. And then it's going to spit out this, and then go to table. I know I'm going a little backwards, guys. I'm running out of room. You go to table, and then it'll print out this. It'll say X, which is really N, if you remember. It'll say X, and then it'll say Y1. It'll say 1, 2, 3, 4, 5, 6, and it'll have all these decimals along here. Well, on this particular problem, 0.5, the fifth polynomial is a little bit bigger than this, and then the sixth polynomial right here, this one, is the one that'll be smaller than 0.0001, and that will give you that it's the sixth term polynomial that will give us an error that is less than 0.001. We'll talk about this one in class. I don't have my calculator here and the correct camera, so I can do it over for you guys. But if I do get it this weekend, I'll get it to you. But hopefully this helps. Just remember, you're going to use all this given information. And I know I went all over the charts on you guys. I don't like writing them on these small ones, but it is what it is. And then we're going to use the error, which they give us to already. But the given information is going to, let me highlight it again to kind of drive it home. I'll do it in red here. The given information is going to get us to this point and this point. And then from there, we just substitute. Once we do all the algebras, little algebra tricks, you can type this in the calculator a little differently, but we let n equal x right here, and then we use the table in the calculator. It takes a lot less time, guys. So hopefully that helps you guys. I'll keep tackling this stuff for you. Keep pounding away. Keep asking me questions, because the only way I learn this stuff with you guys is end up you guys asking questions also. Keep going. Let's keep mathinating.